In our last episode, we explored quantum communication, an unhackable network powered by the bizarre physics of entangled particles. But that technology isn't rising in isolation. There's a reason governments are scrambling to encrypt their data now. A reason scientists are racing to rewrite the very structure of the internet. That reason is quantum computing. A technology so powerful it could break every code we rely on, and then solve the unsolvable. It begins, as always, with a different way of thinking. Classical computers, no matter how fast, speak a binary language, zeros and ones, flip billions of times per second to solve problems. But the natural world doesn't work in binary. It works in probabilities, in interference, in entanglement. Quantum computers embrace that chaos. They use quantum bits, qubits, that can exist in multiple states simultaneously. And when qubits become entangled, they form a kind of computational orchestra, where the state of each depends on the whole. Instead of trying one path through a maze, a quantum computer explores all paths at once. Instead of asking one question, it asks every question, simultaneously. This means certain problems that are practically impossible for classical computers become tractable. Encryption? Cracked. Chemical simulation? Solved. Climate modeling? Reshaped. Drug discovery? Accelerated. And it's not just theory anymore. In 2019, Google's Sycamore processor performed a calculation in 200 seconds that would take the fastest supercomputer 10,000 years. That moment, coined quantum supremacy, wasn't useful in itself, but it proved a point. Quantum advantage is real. Since then, the world has quietly entered a new era. IBM has released its Eagle processor with 127 qubits, and it plans to launch a 1121-qubit chip called Condor. Their Qiskit runtime has already been used by researchers to explore quantum chemistry and fluid dynamics. IonQ, using trapped ion qubits, has built machines with high fidelity and stability, and now offers them via the cloud. PsiQuantum is developing photonic quantum computers using silicon chips that can integrate into existing semiconductor fabrication lines. In China, researchers at the University of Science and Technology have developed a photonic quantum computer capable of achieving quantum advantage in certain mathematical problems. Even Amazon and Microsoft now offer quantum computing platforms, Bracket and Azure Quantum, giving researchers and startups access to hardware from around the world. And we're starting to see real-world use cases. Volkswagen used quantum algorithms to optimize traffic flow in Beijing. Goldman Sachs and JP Morgan are exploring quantum solutions for portfolio optimization and risk analysis. Biotech firms are using quantum simulations to model enzyme reactions that were previously beyond classical reach. In logistics, DHL and D-Wave have partnered to explore routing optimization using quantum annealing systems. In aerospace, Airbus is funding quantum research into aircraft design and fuel efficiency. These aren't hypothetical. They're happening now. We're still in the noisy intermediate-scale quantum era, NISQ for short, where machines are small, error-prone, and imperfect. But the trajectory is clear. The field is advancing faster than anyone predicted. And this is where we need to pause. Because if this kind of technology fascinates you, if you want to understand the future before it arrives, make sure to like this video and subscribe. We've got more episodes coming that you won't want to miss, because the deeper you go into the quantum world, the stranger and more powerful it becomes. Back to the story. Despite the hype, quantum computing still faces immense engineering challenges. Qubits are fragile. They decohere, lose their quantum state, in fractions of a second. Shielding them from noise, stabilizing them long enough to perform calculations, and scaling up to useful sizes are tasks that require bleeding-edge materials science, cryogenics, and quantum error correction. But the stakes are colossal. Imagine a computer that could model an entire protein folding sequence in minutes. A machine that could predict the impact of climate interventions with uncanny accuracy. A system that could crack today's encryption, yet build new security systems immune to attack. And perhaps most profoundly, a tool that can simulate the quantum fabric of reality itself, testing string theory, decoding dark matter, even illuminating the conditions of the early universe. No wonder the world's tech giants and superpowers are investing billions. No wonder DARPA, the EU, and China's Ministry of Science and Technology are funding quantum moonshots. This isn't just a race to faster computers. It's a race to a new kind of knowledge. A machine that doesn't just compute. It understands. And as that understanding grows, the boundary between what is computable and what is knowable will begin to blur. So, what happens when the first true quantum computer comes online? Whoever holds that power will shape the future, not just of technology, but of economics, warfare, medicine, and even philosophy. Because in the quantum age, it's not about being faster. It's about being first. If this episode opened your eyes, stick around for the next episode, where we reveal the global quantum arms race, the secret labs, the strategic partnerships, and the silent war being fought behind closed doors, for control of the most powerful machines ever built. The future is already entangled.